everyone. Welcome to the course of Microprocessor and Microcontroller subject. So in today's class, we are going to learn about difference between microcontroller as well as microprocessor. Okay. So before getting into the subject of microprocessor and microcontroller, we need to have a basic knowledge of actually what is a microcontroller and what is a microprocessor, how both are differ from each other. Okay. So let's see few of the points. Okay. How these two differ from one another. Okay. So coming to microcontroller, it consists of a CPU, central processing unit, and memory devices, input and output devices like IO devices, and timers all on a single chip. Okay. So a single chip holds all the central processing unit, memory devices, IO, input output devices, as well as timers. Okay. Coming to the microprocessor, it is a standalone CPU. It's an individual CPU and memory unit, input output ports and timers are externally connected to it. Okay. So if you see the diagram under the microcontroller and microprocessor, under the microcontroller, on a single chip only, there is IO ports, CPU, memory called RAM and ROM, and interfacing ports as well as timers. But coming to the microprocessor, there is a chip called central processing unit, which is standalone, that is individual, and remaining all the IO ports or outputs, memories, timers, everything are externally connected if through a bus. Coming to the microcontroller, it uses an internal controlling bus. Coming to the microprocessor, it uses external bus interface, memory, and IO devices. Okay. So everything is externally connected using a bus. Now coming to the microcontroller, it is the brain of an embedded system. Embedded system is nothing but it is a combination of hardware and software which is designed for a specific task. So mostly embedded systems are manufactured with the brain using a microcontroller. Now coming to the microprocessor, it is the brain of a computer system. Mostly all the PCs and all the computers uses microprocessor for multiple tasking. So coming to the microcontroller, the circuit size is very, very small. And coming to the microprocessor, the circuit size compared to the microcontroller is large. Okay. Coming to the microcontroller, it is very much simple and very cheap. And coming to the microprocessor, it is somewhat expensive and also complex. So microcontroller consumes very less power, and coming to the microprocessor, it consumes very high power. Okay. So for microcontroller, mostly we will be going with the C language or embedded C. So less number of instructions are required to program any logic. Okay. Coming to the microprocessor, large number of instructions are used. Suppose we use an assembly language program. Okay. So large number of opcodes or instructions are used for the microprocessor. Coming to the microcontroller, the clock speed is very, very less. If you take an 8051, it will be 11.0592 megahertz. It's in the megahertz of frequency. And coming to the microprocessor, the clock speed will be very, very high compared to gigahertz with respect to the gigahertz. Again, coming to the microcontroller, we are here talking about the ICs. So microcontroller will be having an idle mode as well as power saving mode. Okay. So these can be used whenever required. Okay. So coming to the microprocessor chip itself, it does not have any power saving features. Once the chip is used in any particular devices like laptops and PCs, those systems will be externally providing those power saving features such that we can use for the PC or a laptop. Okay. So coming to the microcontroller, as the instructions are very less and the coding is very less, execution will be faster. And coming to the microprocessor, as the instruction set is very complex or we are using an assembly language kind of program, okay, the execution of an instruction is somewhat slower compared to the microcontroller. Okay. So as a microcontroller we are using, it is specially designed to perform a single or a specific task. Okay. And microprocessor mainly used in PCs and are used to perform multiple tasks. The best example of Microcontroller is like robots, home appliances, which are specially designed to do a particular task or perform a particular operation. So for this, microcontrollers are used. Where coming to the microprocessor, PC is the best example of using a microprocessor. Okay, so 8051 Arduino development board, which will be using Atmega 328 microcontroller, are some of the few famous microcontroller boards in order to design the embedded systems. Coming to the microprocessor, as we will be learning 8086 and Intel chipboards, which are used in PCs, are a few famous microprocessors, okay, which are widely used in the computing systems. Okay, so these are the main differences between the microcontroller and microprocessors.